Have you ever stopped to think if you're actually seeing the world in real time? Well, today we're going to dive into a concept that might just change the way you look at everything, especially the night sky. We're talking about the light year and how it proves that our universe is the ultimate time machine. Let's get into it.
So let me start by asking you a really simple question. As you're listening to this, are you seeing things exactly as they are right now, in this very instant? The answer, which is kind of mind-blowing, is no. Everything you see, and I mean everything you've ever seen, is in the past.
And yeah, I really do mean everything. Even the person sitting right across from you. The light bouncing off their face takes about 3.3 nanoseconds to get to your eyes. It's a ridiculously tiny delay, for sure, but it's not zero. You're literally seeing them as they were a few nanoseconds ago. So what happens when we take that tiny delay and scale it up to the size of the cosmos?
Okay, so on a human scale, we're talking about nanoseconds. But to measure the universe, yeah, we're going to need a much bigger ruler. And that, my friends, is where the light year comes in.
So what exactly is a light year? Now don't let the name trip you up. It's not a measure of time. A light year is a measure of distance. It's the absolutely staggering distance that a single beam of light can travel in one full year. To even begin to wrap your head around that distance, you have to understand the speed. Light just blazes through the vacuum of space at an incredible 300,000 kilometers per second. That is the ultimate speed limit in the universe. Nothing can travel faster. It's the law.
So what happens when you let light travel at that insane speed for one entire year? You get this number, 9.5 trillion kilometers. That's a single light year. It's a number so big, it's hard to even imagine, but that's the ruler we have to use to measure our universe.
And this is where things get really cool. Because light takes so long to cross these immense distances, it means that every telescope is basically a time machine. When we look up at the night sky, we are not seeing the stars as they are now. We're seeing them as they were deep in the past.
Let's start close to home, with our sun. Light from the sun takes about 8 minutes to reach us here on Earth. Just think about that for a second. If the sun were to just, poof, suddenly vanish, we wouldn't have a clue for a full 8 minutes. The sun you see in the sky is always the sun from 8 minutes ago.
Now let's zoom out, way out. The center of our own galaxy, the Milky Way, is about 25,000 light years away. That means the light we see from it tonight actually started its journey when our ancient ancestors were painting on cave walls. It's light from the last ice age, when woolly mammoths were still around. We are literally looking 25,000 years into the past. This idea right here, this is what really gets me. A star that's, say, 100,000 light years away. It might not even be there anymore. If it exploded in a supernova today, we wouldn't know for another 100,000 years. We just keep seeing it shining in our sky, like a beautiful ghost made of light from a long-dead star.
And you know, this cosmic delay isn't just about what we see. It also has some pretty big implications for how we might one day communicate. So what would it be like to have a conversation across the stars? Let's imagine the ultimate long-distance call.
Okay, so let's say we find a planet 2,000 light years from here. We send a radio message, a simple hello. Our signal, traveling at the speed of light, takes 2,000 years just to get there. If some civilization on that planet immediately replies hello back, their message takes another 2,000 years to reach us. That's a 4,000-year conversation for a simple hello. It really puts the scale of the universe in a whole new perspective.
All right, so let's put it all together. Let's take one last journey. A rapid zoom out, starting from our own cosmic backyard all the way to the very edge of everything we can see.
Light takes just 1.3 seconds to reach the moon. Okay, 8.2 minutes to the sun, manageable. 4.3 times years to get to the next nearest star system, whoa. It takes 81,000 years just for light to cross our own galaxy. And the most distant light we can possibly see? That light has been traveling for 46.5 billion years. We are looking back to the dawn of time itself.
So, at the end of all this, we're left with a pretty strange reality. We can only ever see the universe's past. The present moment across the cosmos is forever hidden from us. It makes you wonder, doesn't it? What does the universe actually look like right now? Now that's something to think about the next time you look up at the stars.